Now we have the last paper, that is the capacity development for sustainable dam safety measures by Dr. R. Krishnan.
Chairperson, co-chairman and rapporteurs, learned delegates and my colleagues. I am Dr. Krishnan, Executive Engineer of Water Resource Organization, Tamil Nadu, presently working as a Deputy Chief Engineer on deputation in WAPCOS Limited. It is a PSU under Ministry of Water Resource. It is an international consultant dealing with water, power, infrastructure facilities. So, it is my pleasure to share our experience on capacity development that we have experienced in Tamil Nadu. So dams and reservoirs are constructed to store the water and to meet the different, that everybody knows. But at the same time, the demand is increasing with the increase in population and the adoption of innovations in different usage of water. But to address the issue, there is no scope for construction of new dams. In almost all the states in Tamil Nadu, it is very remote to go for a new irrigation projects. So hence, our urgent is to safeguard the existing dams for to address the continuous usage. So in that aspect, capacity development is the need of the hour to carry out the dam safety measures. So activities related to dam safety measures are diagnostic analysis of dam performance, control measures to comply with the standard directions and regulations, improvements on performance dams and reservoirs, repairs and rehabilitation with our own capacity, or some we can go for the external agency to get the expertise, reduction of potential harms to public, and creating awareness to the public on critical situations. These are the activities that has to be done on dam safety measures. For that, we need a capacity development. So capacity development consists of three components. It is a individual development, organization development, and the enabling environment. We should not limit with individual development alone. If you see that area of integration is the level of ability to achieve the objectives. So capacity development is the process to achieve the objectives. So this is the present scenario. This has to be increased further to to address the issues. So based on this, we have experienced as a third-party consultant in Tamil Nadu during the implementation of IMO project, that is Tamil Nadu. So in that, this is the ultimate objectives. So if you develop individuals, organizations, and providing enabling environment, that is the expected level of ability to be achieved object through capacity development, especially on the dam safety measures. So coming to the case study, WAPCOS at Chennai has provided a consultancy service for capacity development on quality aspects during the implementation of Tamil Nadu IMO projects. It is we have taken a repair, Tamil Nadu has taken a repair and rehabilitation activities in water bodies in 61 subbasins out of 127 subbasins. It is mainly focused on the tanks. It is a small reservoirs. Mostly it is like a small reservoirs. So strategy what we have adapted is, we have collected the data and a diagnostic analysis of the system related with the capacity development on various aspects, human resources, technological aspect, and infrastructural facilities, dam safety measures, financial aspects, and we have identified the gap area, and we have provided a capacity development program for the individual, organization, and enabling environment. So coming to the individual developments, trainings were given for the 350 WRDO engineers on especially on quality aspects. Then hands-on training on quality control testings by the field engineers. Then exposure visit to know the real conditions of how the water bodies are existing in the ground reality, what are the measures to be taken by the individuals. Then capacity development at the organization level is preparation of manual on quality aspects to get the ready reference for the implementers in the field. Then providing adequate facilities by establishing 2 ground laboratories and 3 mobile laboratories. Then institutional strengthening, formation of quality control divisions and establishment of quality control systems and the development of web-based software to control the quality aspects. OK card system was introduced, so in which the ultimate end users that farmers have participated to check the qualities in doing in the execution of work. Then capacity.
Mr. Krishnan, we are left with 2 minutes.
Yes. Enabling environments. So it is we have provided idea sharing platforms, integrated approach by allied departments, then legal frameworks. With these backgrounds, we have provided a capacity development for the water resource bodies. With this, it can be extended for the dam safety measures. The thrust area for capacity development on dam safety measures are diagnostic analysis, decision support system, quality control, quality assurance, establishment of communication network, preparation of manuals, awareness creations on flood warnings, adoption of new technology, participatory arrangements for disaster management. So capacity development is the key role to be performed to the ability to achieve the objectives of the project like DRIP. Expertise available with WAPCOs Limited may be utilized for the development on dam safety measures. So almost you all may not get a chance to construct a dam. Being a technocrat or being a citizen, let us join together to safeguard the existing dams through dam safety measures for sustainable development of our India. So with this, I conclude my presentations.
Thank you very much, Mr. Krishnan, for doing it exactly in time. And now our floor is open for any questions or anything for about say 3 minutes, and thereafter then we would like to have the opportunity to express the thoughts about our co-chairman and report chair. So we have about 3 minutes in which
there is better coordination among the civil and other disaster related organizations.
yeah, anybody from the state dam safety organization can answer. Primarily the Ravi, yeah.
Mark 3. The coordination is not something which is going to be automatic. So there has to be a mechanism to make that coordination as part of a plan, and then it has to be communicated and it has to be put into implementation. And the framework for that is what we call as an emergency action plan. So emergency action plan is not merely for a disaster scenario. Actually, it's something which is a pre-runner. Disaster should not happen. So in terms of disaster also, it's 2 scenarios. One is that the dam break is happening. Another is dam is not going to break, but there is an extreme flood which is released to the spillway. In both the cases, the emergency action plan has to come into play. So within the emergency action plan, you come to know the scenario in terms of downstream impact. So you know which are the areas which are going to be inundated. You know which are the prominent structures like railways or road bridges or maybe industry which is going to be affected. And then you are supposed to know how to communicate to the concerned people, including the state disaster management. All that is supposed to come within the emergency action plan document. So once the document is ready, you will go through an exercise of mock drill, etc., so as to keep everyone on board. And when actually the incident happens, you will be able to put into effectiveness. As of now, since we do not have many of the emergency action plan, So the question is very correct. Actually, we are not in that mode where we can actually do much of the coordination with these authorities.
Sorry, sir. Like, sir, actually,
There is practically no involvement because we do not have the emergency action plan. In fact, we do not know whom to put into the coordination link. Only an emergency action plan document only will make it possible to know that who are the authorities, which districts are likely to be affected, how and when to contact them. All that is supposed to become part of the emergency action plan document. Unless that document is ready, practically, we do not have a very scientific approach about this coordination.
Thank you, Dr. Pillai, for evaluating the situation. Now, I would take this opportunity to request our co-chairman, Mr. June, to say a few words for about, say, 2-3 minutes.
Thank you, Chairman. And thank you for all the presentation. Gained a little bit of confidence that we are in the right direction, although requirement or the needs of the training, we need to explore more. Because we, until today, our dam rehabilitation project, as a task team leader of that project, we have been struggling so much to make our actual construction to progress on the ground, and that needs of especially the state level training requirement has not yet been discussed in detail. We were literally depending on our Aegis consultants friends to assess the needs and actually do the implementation of the trainings. Partially thanks to the Japan Water Agency guys here, who has also contributed to have about 40 to 50 engineers from India to participate in the training program in Japan also. Last but not least, I was pretty impressed with Angus' presentation on the dam portfolio management. And that's the direction of the dam assessment, asset management that I like to see that in India that we make progress too. For that, I was very happy to see Tom Kendall's presentation on Dharma, where we finally started to build our own dam asset management database, which we are now trying to start with our 9 agencies of the DRIP families, which we will expand to all the states who has a dam operators and dam managers and owners in India also. These are the future direction of the dam rehabilitation and improvement in India, and I look forward to having further cooperation through the World Bank activities. Thank you, Mr. Chairman.
Thank you, Mr. June, for providing a very clear view of the progress that we have to make in the DRIP program implementation. I would also like to give 2 minutes opportunity to our reporter, Dr. Arun Kumar, also to express his thoughts on this before we conclude.
Thank you, Chairman. About the presentations, which you already have listened to them, and then also the efforts which are being made in country, and the requirement actually is very huge, and that way, and especially the last question and answer when Ajay has raised a very pertinent question that our preparedness in terms of the coordination with the state disaster management and as well as the national disaster management, I think this particular thing has been highlighted very well. And one thing I like to say is, because being the teacher myself here, and then I would like to say in terms of the capacity building is especially the Mr. Chaskar and Krishna also mentioned that it is not only a theoretical, rather than it's also the practical aspects of the capacity building is also very much needed. But well, in that sense, our presentation we started with the Angus, where he's spoken about this Australian Tasmania's management way of risk management, and I think with this the very efforts of capacity building are being highlighted, and I think with the governments, state government, national government, are going to do or are taking the right actions in the direction, though it was late, but even then it's nice that to hear that all this portfolio management of Dharma and this web management is doing very well. So with this, I give that's all. Thank you.
Thank you for making this program really happen. So capacity building is a very important topic. More than that, actually, I feel that we also need to develop a thought process about the quantifying the risk pertaining to the dams in the country and prioritizing based on the quantified risk parameters. This is something which we haven't yet been able to do. Even though I do remember that in the earlier part of our dam safety assurance and rehabilitation project, if I'm not wrong, Mr. Gopalakrishnan as Director R&D worked out a base framework for training, etc. We did undergo some kind of trainings, but the quantification of parameters is something where a lot of thought is required at the country level, so that we are able to really assign a number to the individual issues of dam safety and consequently prioritize the dam, so that we are in a position to focus the funding on the places where it is actually genuinely required. There, this hazard classification has been a very big challenge for us because in our country, being a highly overpopulated country, unfortunately the loss of lives is something which kind of derails the entire classification, and all the dams land up getting put to the highest category. So these kind of challenges are there that we need to really address for quantifying the risk, and based on some kind of a index parameters, based on some kind of a assessment on a quantitative way, we can then allocate our resources for the dam safety program across the country. I thank the organizers for having given me the opportunity, and all of us that we could participate in this very enlightening session, and let us hope that we will be able to bring these recommendations forward. Thank you very much.
To all the presenters, so I will request our chairperson to give a token of thanks to our presenters. I'll call upon the name, please, if you can. Mr. Tom Kendall. Mr. M. Bhaskar Reddy. Mr. D.S. Chester. Dr. R. Krishnan. And this time our Deputy Sir, Professor Arun Kumar. At this time, I would like to request our co-chair, Mr. June, please, can I give a token of thanks to our chairperson, Sri Evi Padyasar. We have missed out to represent token of thanks to our chairperson, our co-chair, and deputy and the presentation. If I'll just quickly call the name, and I'll ask Mr. June if they can represent a token of thanks to Shri M. Gopalakrishnan sir, if he's here. Yes. Sorry about that. Shri Vivek Tripathi, he was the rapporteur for the session. Mr. Gopal Krishnan was the chairperson of the technical session number 1, which was health of aging dams and corrective. Thank you. Shri Vivek Tripathi, thanks. And we have the presenters there. Mr. Ed Flint, if he is there, available. R. Mahajan. Mr. Ed Prince here? Yes. Thank you. Response forms there in the bin. And if you have not received the response forms, please select it from our volunteers, and then you can put it in this response form there. And the second announcement, sorry about that. The second announcement is basically about a course. The Department of Hydrology is organizing a course from April 3 to April 8, 2017. It's on the emerging hydrometric techniques for discharge estimation and rating curve development. It's the course which is under the GYAN program, which is a global initiative of academic network. So if whoever is willing or who is interested in this course, for the students and for the people who are working, you can connect the brochures from this side, and the brochures will be available on this counter. Thank you very much, sir. Thank you, Chairman, sir. Thank you very much.
And we have been given this session was supposed to start at 1:30, and about 80 minutes is there. So what we are going to have that each presenter should restrict his presentation to 10 minutes, so that we should have about 20 minutes for question and answer session. So without taking much time, let us start the session, and then after that we'll have the question and answer in the end, and we will try to complete this session within the stipulated time.
Able to share with all of you our experiences on risk analysis techniques applied in several case studies in Spain and also in other countries worldwide. So then I'm a civil engineer and I work for Empresas Risk Analysis. It's a spin-off company of the Polytechnic University of Valencia in Spain. And we are specialized on applying risk analysis techniques to support dam safety management. So then, Spain has a long tradition on dam construction and dam safety management, mainly influenced by two dam failure events, one in the 60s and another one in 1994 at Tous Dam. This is the left picture is the flood event. So then these two failure events influence our regulatory context, and also we are also in line with European directives on flood risk and critical infrastructure management. Also, we have been inspired by international dam safety guidelines that are now widely applied by the dam safety community. So then Spain is in the top 10, within the top 10 countries in number of large dams in the world. So then you can see here India is the third country and we are 9th. So then with more than 1,000 large dams. And they are distributed across the whole country from north to south to solve the past and current needs for water supply, for flood risk protection, and drought, and to solve also drought risk mainly in the eastern part where I'm from. So then this is the framework that we applied in the last years with several landowners, public and private. So then they are, many of them are required since 1996 to implement emergency action plans, to develop frequent periodic safety reports. And now some of them, they realized that they had many information available on their code, namely dam safety file. And we were able to use this information on loading scenarios, on system response, on consequences downstream, to incorporate all this information into risk analysis tools to estimate current risk, to evaluate risk, compare with tolerability recommendations, and then being able to prioritize actions for risk reduction. So then we have been working with dam owners on how to develop these risk models, how to inform decisions on dam safety. And now we finished the first loop, this dam safety management approach, with several pilot case studies. In fact, the Spanish National Committee on Large Dams, called SPANCO, published in 2012 a guideline, a technical guideline. It's available for free in their website, to describe the process and to help dam owners to guide this risk analysis framework. So then we have case studies, successful case studies, not only in Spain, for more than 30 dams in Spain. These are examples within the Duero River Authority. But we also have experiences in other countries, in Latin America and also in Europe. So then in this presentation I will just highlight a few results from two case studies, one in Spain and another one, case example B, in Albania, in a project funded by the World Bank 2 years ago. So then for the first case in Spain, we worked together along with the regional government of Extremadura. Extremadura is a wonderful region in the western part of Spain, near Portugal. And then we conducted 3 analyses for 3 dams, 1 earthen dam and 2 concrete gravity dams. In fact, one of them, Jaime Flores, had an overdoping event in 2000. So then the dam owner was really aware of the current risk for these 3 dams. So then that's why they selected these 3 pilot cases. And then we developed the risk model architecture for all of them. This is the example for the third case. So then this is the risk model. It represents in a compact way the event tree model that we use to combine all failure event probabilities, failure probabilities, and consequences to estimate risk, and then being able to compare scenarios and prioritize investments. So then it's known of this risk model includes information from monitoring systems, from safety reviews, from dam site inspection visits, from consequence estimation procedures. Then we combine all this data to estimate risk, and So then, you may say we developed software tools for risk. This is called, we have 2 main modules. One is Empresas Calc for risk calculations. Then we may include results from different models, structural, hydraulic models, and then compute risk. And the other one is called Empresas Manager, is for portfolio risk assessment. So then, for this case example in Extremadura, we consider all this set of risk reduction measures that were planned by the dam owner, and then we implemented different scenarios to obtain and represent risk for the 3 dams. The vertical axis represents the annual failure probability, is the FN graph commonly used by the dam safety community, and the horizontal axis is the average life loss estimation. So then these dots, these 3 lines, represent the sequence of measures required to lower risk from all the 3 dams. So then this is the current situation for El Horcajo Dam. So then, but after implementing different measures, then we may reduce risk and be in line with international tolerability recommendations. So then this is the optimal sequence of measures that we took the first 4 measures. So then they had a list of 17. So now with these results, they were willing to choose the first one and the second, and then now they are implementing these 4 measures, improving, mainly one of them is improvement of dam surveillance, upgrading the monitoring system in El Horcajo Dam. So now they have the tool to prioritize this list of measures, because from the beginning they didn't know how to start or which one was the most